We're going to use the bootstrapping tool in iNZight to make a comparison between two samples and to see if we can make a call that back in the population, one group is bigger than the other. The first thing we need to do is we need to format the data in Excel. Often, when we get our data, it looks like this. We have two columns. In this case, we've got heights of some Year 10 students and some Year 11 students, and the data is in two columns. Now that doesn't work when we try and import the data into iNZight. So what we need to do is we need to change that. And what we need to do in terms of changing it is we need to put it and make it look like this one. So what you have is you have your groups. In this case, we've got Year 10 students. So we've got all of these Year 10 students and their heights in the column next to it. And underneath, we have the Year 11 students and their heights. Okay, so fundamentally what it means is we've got the school year here and the heights here. All right, so all of the heights are in one column. What we need to do then is go to our iNZight program, click the Bootstrap confidence interval construction and run that module. When that comes up, we then have to import our data. Make sure you've saved your spreadsheet to a place where you can find it easily. I've saved mine to the desktop, so we have a look for that. And it's that one there, heights of year groups. Click on OK. OK again. And it imports the data into there. We then need to select the variables down here. So we've got the school year and we've got the heights. Okay. What that does is it creates a dot plot over here. In this case, we've got Year 10 heights here and Year 11 heights here. Now, what we're going to need to do is then click on Analyze. We're always looking at the median with our bootstrapping. Record those choices. And what that puts on there is it puts on the box plots of the Year 10 and the Year 11. In this case, in this sample, it seems that the Year 10s are actually taller than the Year 11s. And the difference between the medians is 1 centimetre. It's that difference that's really important, because what this bootstrapping thing does is it calculates the difference. When you resample it, it calculates the difference between the two medians of 1,000 resamples. To show you what that means. So if we click on 1,000 of these resamples, click Go, and let it do its thing. You can see the resamples happening here, and what we've got is we've got sometimes a resample, the median of the Year 11 is bigger than the Year 10, and vice versa. Down here, what it's doing for every resample, it's calculating the difference between the two medians and putting them down here as a dot plot. So you can see it's taking away the Year 11s from the Year 10s, because the Year 10 was the biggest one in the first instance. So all of the ones this side of the zero, all of the resamples this side of the zero, was where the median of the Year 10 is bigger than the median of Year 11, and the ones this side of the zero, the median of the Year 11 is bigger than the Year 10. If we then put on our confidence interval and let that do its thing, then what we get is we get this confidence interval of -5 to 7.5. That means that we can be 95% confident that the difference of the medians in the population is between -5 and 7.5. Now, because this difference spans the zero, we can't make the call, because some of the samples, one median is bigger than the other, and in some of the samples, the other median is bigger than the other. What we need to be able to make a call is for this confidence interval, or both limits of this confidence interval, to be bigger than zero. And that's what we're always looking for when it comes to using this bootstrapping technique to make a call about what's going on in the population.